Welcome learners for the lecture 11 of a differential geometry. Today we will discuss about the definition of this form in the tangent to the normal of this condition. Okay. The anchor ring is a surface generated by the rotating a circle of a radius a about a line in its plane at a distance b is always greater than a from its center. This circle does not meet to the axis of a rotation, whereas in this case sphere the curve is a semicircle meeting to the axis of rotation is a 2 point. Theorem will be considering in this form the position vector of the point on its anchor ring is a r equals to b plus a cos u cos v, b plus a cos u sin v and a sin u. This will be generated x, y, z axis, both of these conditions. Where b00 is the center of a circle and z axis is considering as a rotation in this form. Taking the axis of a rotation as a z axis and generating to the circle in the xoz plane with the center c b00 on the x axis, we shall first the coordinate of the point on the circle will be generated. Let CA make an angle U with the axis x. The x coordinate of a is a b plus a cos u and the z coordinate of a is a sin u. Hence, as in the figure, it has a coordinate point will be generated. This x-axis will be generated to the circle of the sphere will be considering this point to the C point to the 0 is a B point. A to C will be considering this is a point will be considering and U has the coordinate of and Z axis considering as a coordinate B plus A cos U 0 and A sin U. Y does not considering to the any coordinate. Okay, let P x y z be the position of the point after the generating circle is revolved around throughout the angle V. Since the A is described to the circle about the z axis, the distance of the point P in this axis, z axis is the radius of this circle by generated as a value b plus a cos u. Since it has been revolved through the angle of the V, its xy coordinates generating b plus a cos u cos V, b plus a cos u sin V in this form. For the point A as well as the point P, its coordinate a sin u is always constant and the position vector of the point P on the anchor ring is given as to the form same as is considered as a sphere to the form b plus a cos u cos v, b plus a cos u sin v and a sin u in this form. Okay, where to generated to the value of this equation and generating to this equation as a form, generating to the value as a form to considering as a equation, that is where 0 is less than u is less than 2 pi, because whole ring will be considered or the sphere will be considered, they always as a considering as a circle in this form, that is a 360 degree in this. Both of these conditions u and v will be generated 0 to 2 pi. When u equals to constant, CA is a fixed and revolved about the z axis, hence it is the circle on the anchor ring and these curves are the parallel. When v equals to constant, the rotating plane is a fixed. Hence the parametric curve for the 0 is less than u less than or equals to 2 pi is the intersection or the cross sectional of the plane and the anchoring, so that it is generating as a circle in the meridian of the form. Hence meridian are the circle in this form. Then R1 will be show that is a minus a sin u cos v, y considering minus a sin u sin v and y considering z considering a cos u and r2 considering in this form, that is a minus sign of a b plus a cos u sin v, b plus a cos u cos v and 0 in this form. Since r1 dot r2 equals to 0, the parametric curve are orthogonal and r1 cross r2 equals to minus b plus a cos u cos v, a cos u sin v and a sin u in this form. Since b is greater than a, the above vector is a negative for the range of the value u and v. So to the normal is directed inside to the anchor ring. Hence they will be sure that is a mod of a r1 cross r2 is always positive form of this equation. They both of these depending on the r1 and r2 for getting to the value r1 cross r2 in this equation. When in the figure will be showing z axis will be generated normally as a 0 in this form. In a r2 position, r1 will be considering as a cos.